So, today we're looking into the regions on the complex plane. And we can define many lines using complex numbers. For example, let's consider how we can, let's find the equation of the perpendicular bisector if we have two complex numbers, Z1 and Z2. We have line connecting them, and we need to find the equation of the perpendicular bisector. What does it mean, perpendicular bisector?
No,
It's at 90
at
degrees.
the midpoint.
Line that intersect the line segment connecting them, intersect at the right angle and in the midpoint. In the midpoint. So how we do that? That means each point on this line has to be equidistant from those. How we express the distance between the point Z and another point on the complex plane? We write Z minus Z1 modulus. That is a distance. And if we have, let's do on the example, let's take point Z1 is 1 plus 2i, and point Z2 equals 3 plus I. 3 plus I. So, and let's take Z as x plus 1, I, equal x plus IY. So, this is a distance, we say equidistant. That means we find in the locus of the point, Z minus Z1 modulus equals Z minus Z2 modulus. That will be perpendicular bisector, because all points on the perpendicular bisector are equidistant from Z1, Z2. Make sense? So let's do x plus IY. So we will have x plus IY minus 1 minus 2i equal x plus IY minus 3 minus I. How we find them? Now let's rearrange it a little bit. Write it as x minus 1 plus y minus 2i modulus equal x minus 3 plus y minus 1i modulus. I just collected real parts together and complex and imaginary
Parts
parts.
together and complex.
And imaginary, because it's all together, it's complex.
Yeah.
Now, how we find in the modulus? The modulus will be square root of x squared plus y squared, modulus of the complex number. So it will be x minus 1 squared plus y minus 2 squared equal, now square root of x minus 3 squared plus y minus 1 squared.
I don't really get what you did there. There's two moduluses. What are you doing there?
This is
Yeah.
we saying that the points on the perpendicular bisector are equidistant. This is a distance. This is a distance from some point with the x plus iy on this line minus z minus z1. Our z1 is 1 plus 2i. So z, any point on this line, minus given point, first point, and modulus is distance from this point to our z1. And that distance, this distance, which is this, has to be equal this distance. which is this, z minus z2.
Yeah.
Then I just rearranged, collected the real parts together and imaginary parts together. Put modulus here, real part together, imaginary part here.
Yeah.
And distance is this between 2 points. Remember distance formula? y2 minus y1 squared plus x2
So
minus x1.
this
This is the distance from point xy to z1. This is to the z2. And they must be equal.
Imaginary is the one.
Imaginary is 1. So then we need to just square both sides, get rid of the square roots, and we get x minus 1 squared plus y minus 2 squared equal x minus 3 squared plus y minus 1 squared. Then we just need to expand brackets and simplify it. And it's obvious, should be obvious for you guys, that x squared here and x squared here, because it will be 1x squared, they cancel out. Y squared and y squared there will cancel out, because we have here 1x squared, here we'll have 1x squared, here 1y squared, here we'll have 1y squared. So they will cancel out. So we will not even write them down. So we have here minus 2x plus 1. I'm not writing x squared because we know that it will cancel out. You can see that. Plus, not plus, minus 4y plus 4 equal, here we have minus 6x plus 9 minus 2y plus 1. I expanded brackets and I just get rid of x squared, y squared. Let's collect like terms, move everything with y on one side. So move 4y there, minus 2y, we have 2y on the right, on the left we have minus 2x plus 6x, we'll have 4x, and we have plus 5 minus 10 minus 5, 9, 1, 10, 5 minus 5, then divide by 2, an equation of the perpendicular bisector will be y equal 2x minus 5 on 2. And as we expected, we achieved the Cartesian equation of the straight line. And this straight line will be perpendicular bisector between points 1 plus 2i and 3 plus I. Make sense? What we did. So that's how we find a perpendicular bisector. We equalize distance from point x plus iy to one of the given points and to another point. We equalize moduluses and then just find the equation of the line. Yes?
So this is like the only way to do it. You can't do it like you can in methods, like where you can find the gradient.
Is there a gradient for?
Okay, we can. This will be what the coordinate of this point 1, 2.
Yeah.
This point 3, 1. You can find the gradient of the line connecting them. You can find midpoint. You can find the gradient of the normal and find the equation of the normal. You can do it in the way that you were doing in method.
That feels like more simple, or at least easier for us because we're used to.
So in the special exam, if they ever ask like on 3 or 4, if they ask you to do this, and I do this in methods form, that is it fine?
I don't remember on the exam the perpendicular bisector. Usually it is more complicated lines
So that's
than
why.
the perpendicular bisector.
Yeah.
But pretty much if you do in this way, you can do it in this
So
way.
why would we do it this way?
I feel like this way would be quicker if you get more used to it as well.
This
This
is the method.
no, this is to
Yes.
get an idea
You don't have to-
how we're finding equations of the lines in the complex plane. Now, another equation, another type, circle. How we can define circle in a complex plane? Equation of the circle in the complex plane. Because we can define ellipses, circles, hyperbolas, ellipses, and one more thing that you've never done in methods, rays.
Right?
Rays,
Oh,
Right.
right.
like ray of light.
Yeah.
So, let's do circle. What is circle? How you can, in words, explain what is circle?
It's a circle is something with equal distance to each point.
To each point.
To each
the
line.
points which are
From this-
which
from
are
this-
equidistant
From the center.
from the center. So let's say our center is Z1, and we're looking for points, so Z minus Z1 modulus, because this is a distance, equal radius.
Z,
Yeah.
Z is the center. right?
Z1 is the center. Z is any
the
point
point,
on the
yeah.
circle.
That
We
makes
have point, we have Z1 is the center, and all those points are Z, X plus IY. And they all distance modulus of this difference, so it's a distance equal R. So let's say find the Cartesian equation of the circle. If we have Z1 equal, let's say 2 plus I, and R equal 3. Let's find the equation of this. So you can do it in methods. Pretty much in methods way it will be very similar to what we will be doing.
So you
Because we
want to
have
find
x, we have x plus iy minus 2 minus I minus z1 modulus equals 3.
Mhm.
This again we rearrange with the real part x minus 2 plus imaginary part y minus 1 I modulus equals 3. Modulus is square root of x minus 2 squared plus y minus 1 squared equals 3. Which is the almost equation of the circle. What we have left to do?
Just square.
Square both sides, and we get equation of the circle. X minus 2 squared plus y minus 1 squared equals 9, which is the equation with the center 2, 1, and radius 3. Make sense? But there are more complex ways.
Oh no.
Does that make sense?
Yeah.
There are more complicated questions. Let's say okay, let's consider the next thing. Find the Cartesian equation of the next relationship. If we have z 2 times z plus 1, 2 times modulus z plus 1 equal modulus z minus I.
So what
Looking, we need to find Cartesian equation. What line is that? So,
What question is this?
it's not from the book. So we have 2 times square root of x plus 1 squared plus y squared equal square root of x squared plus y minus 1 squared. Do you understand how I got this, or I need to intermediate?
Yeah, I understand what.
Are you finding Cartesian? We have relationship given in the complex form.
So
We
why is it,
want to find what is the Cartesian equation of this line.
why is it x plus y?
Because we have z plus 1, z is x plus iy
Yeah.
plus 1. Then we have real part x plus 1 plus iy.
Okay, that makes sense. Thank you.
Let's square both sides. We have 2 square roots, let's square both sides. We have 4 times x plus 1 squared plus 4y squared equal x squared plus y minus 1 squared. Let's expand. We have 4 x squared plus 8x plus 4 plus 4y squared. I expanded left hand side, right hand side equal x squared plus y squared minus 2y plus 1. Collecting everything with x and y, everything on one side, we get 3x squared plus 8x, 3x squared plus 8x. We have plus 3y squared, and we'll have plus 2y and plus 3. 4 minus 1 equals 0.
And you just complete the square now?
Now, let's divide everything by 3
Okay.
to make x squared and y squared 1. X squared plus 8 on 3x plus y squared plus 2/3 y plus 1 equals 0. And now we complete the square.
Yeah.
Now we complete the square. We get x plus plus what?
Half
4
time.
on 3, half of this,
Yeah.
plus 4 on 3 squared, minus 4 on 3 squared, plus y plus 1/3 squared, minus 1/3 squared, plus 1 equals 0. So we got x plus 4 on 3 squared plus y plus 1 on 3 squared. Now we have minus 16 on 9. We have minus 1 9, so it becomes minus 17 on 9
Plus.
plus 1. So will be equal 8 on 9.
So as soon as you saw that it was x squared and y squared, you knew it was going to be a circle.
Yes. So we got a circle with the center negative 4/3 and negative 1/3, and the radius 2√2 on 3.
Would it always be a circle in these scenarios?
No, we can get. We will not be doing this this year. We'll be doing it next year. You can get in this way. Through complex numbers, we can define ellipses, hyperbolas, parabolas, all known stuff to you. But this year, you will be doing it next year. This year, only one more thing, rays. And ray is very, very simple to describe. What will be common for the next line? If we have a Cartesian plane or complex Argand diagram, and so this is this is real Z, and this angle, let's say pi on 6. I put open circle here. This point not included, because this point doesn't make any pi on 6. All others does. We cannot make 0, 0, 0.00 in the polar form. Now, how we can describe all those points? What common between all points on this ray?
Same grade.
So, cis. So,
They
same
have
arc.
same make same angle.
Yeah.
And how we call n when we write the polar
Argument.
argument?
Ah.
So equation of this
Oh,
line
what
will
is
be
it? Cis?
argument theta
Mhm.
equals pi on 6. That is equation of this line.
Oh, sure.
That is equation of this line. So argument z,
Ah.
argument complex number is z equal the n.
Mhm.
Argument z equals pi on 6.
So argument just means the grade
Angle.
angle, sorry. Is that all it is?
Yeah, argument. Remember we were making
Yeah,
in the polar form, argument is the angle. So now, how the next one will looks like if we have, let's say, argument z minus 1 equal pi on 6. What do you think how this will looks like?
A semicircle. Semicircle. It says semicircles.
It's
but
a ray.
Like a
No, it's a ray. But it will be translated
one to the right.
1 to the right.
Oh.
So that will be it's 1. That will be
Wait, can one?
argument z minus 1 equals pi on 6.
1, 0 can be written in polar form, kind of.
No.
Why not? The
0. There are
R is
equals
1.
0.
Wait, how? R is 1. 1 squared equals 0
The
squared.
no, distance from this one, no, for this was 0, we can, and then we translated it.
Okay.
Now, what will be if I write argument z plus 2I equals pi on 6.
Well, translating it. Ooh.
Translated
It's the
by
y value. Down, we've got 2R.
2 down. That will be starting at 2.
Is it negative 2R or is it just 2R? That point, whatever it is.
Imaginary equal 2, that means 2I.
It's 2R. Is it
Yeah.
negatives in Argand diagram? Like negative?
It's
Yeah, negative 2R.
2I.
Okay.
Now imaginary z equal minus 2, but we have imaginary z times I. That's how what we.
So there's no need to write I.
So you don't need on the diagram, right? And then this angle has to be pi on 6. And the last thing, if we have argument of,
Why 1? What's the 1? What's the...
That's from the one above.
that was
Oh,
from
sorry,
here.
sorry. Yeah. Does it continue all... Does the rate continue all the time?
Forever.
Whoa.
To infinity.
Forever.
Argument now. Argument z minus z minus z plus 3 minus minus no, plus 2I equal negative
3 right, 3
pi
down.
on 3.
2 I down. 3, no, 3 left.
So where it's starting point?
3 left, 2 down.
Well, it's starting at 0, 0.
It's no, its starting point is
Oh, 3.
negative 3,
Negative.
negative 2, negative 3, negative 2, and what angle it will make?
Negative pi.
Negative pi on 3. So we in the opposite direction. So that will be that rate. This n is pi on 3, but in the negative direction. That's how we define rays.
Rays are cool, I like rays. Yeah.
And yeah, that's all lines on the complex plane for this year.
So
Next
sorry,
year you
what about
get
to-
simple circle and ellipses? What are they? Are they not allowed?
Next year.
Next year.
Okay.
So it's just
Okay, like, subscribe and donate to help fight terrorist countries and organizations like Russia, Iran, Hamas, Hezbollah, etc. Support Ukraine and Israel.